here first, right? What I'm gonna I'm just gonna draw out the basic circuit for the color sensor that we're going to be using. The name of this sensor is TCRT 5000. Oh, black. What happened there?
Did the camera get too close to the lens?
Sir. Oh, maybe it's just because the page is there.
That's the lens blocking it.
That's good. So the name of the sensor that we're using here is TCRT 5000. So it's an infrared reflective color sensor. This is the actual sensor itself here. So you'll have received one of these in your set of parts that you got from your tutor. I think all the teams have got these now. There's two parts to it. I'll just spread out the legs a bit so I can stand it up. It's got 4 legs altogether. And if you look at the front surface of it, you'll see it's got 2 eyes. So it's got a black eye here, and it's got a blue eye here. The blue eye is an infrared LED. So IR LED. So the IR there is short for infrared. And that means it's slightly outside the visible spectrum. So you cannot see the light that comes out of this LED when it's switched on.
It's not all showing up
there.
there.
Is oh.
That's better.
Okay.
It still only has blue eye. Just right in, try dark if you can.
Okay, so as I say, it's got 2 eyes, a black eye and a blue eye. The blue eye is the infrared LED. So the infrared LED has got 2 legs. You can just see the 2 of them there and there. And when you put current through that LED, just like the visible light LEDs that you've been using up to now, it emits a beam of light. Now it's quite a focused beam that comes out of this particular component, so it'll shine out like a little spotlight. Normally this is going to be on the underside of your robot pointing at the ground underneath, and the first thing that you'll use it to do is to detect the colour of the ground under the robot or underneath one part of the robot. So the infrared light that comes out of this when it's pointing at the ground is going to illuminate a little patch of the surface underneath the robot. The second eye, which is the black eye, this eye here, is effectively a light detector. What it is specifically, the black eye, is a component which we call a phototransistor. Now, although you probably wouldn't be aware of this yet, a transistor in electronics is like a component which acts as a valve for electric current that you can switch on and off. So normally in a transistor, a small low power electrical signal switches on or off a much higher power signal or a much bigger electric current. What's different in a phototransistor is instead of being controlled by an electrical signal, it's controlled by an optical signal, so by light. So when light lands on this black eye here, the more light that lands on it, the more electric current is allowed to flow through it. So it's like a valve for current that gets switched on and off by light. Now the reason the plastic which covers that eye is black is to try and shield it from visible light. So the idea is to make it not really respond to the light that we're able to see with our eyes at all, but rather to respond only to infrared light, because that's what's coming out of the emitting side here. So it's basically a reflective sensor. The idea of this is to try to point it at a surface and detect how much of the light is reflected back from the surface. So you shine out a constant beam out the infrared and you look to see how the current varies through the phototransistor, and that tells you about the thing that the light is reflecting off. Now in our case, we're going to hold it pointed at the ground at a fixed distance, and the distance is going to be very, very short, right? So if this is my sensor here with the 2 eyes and the 4 legs coming out of it here, and it's pointing down at the ground, the distance between it and the ground should be very short. So I would say typically about 5 millimeters, maybe up to about 10 millimeters maximum. So you're talking about a very short distance. It's not shining out a huge amount of light out of this, so you want to make sure that you give a sporting chance of that light to bounce back and hit the black eye here. If you hold it too far from the surface, it'll spread out too far before it even hits the surface, and very little will bounce back to be detected by the phototransistor. So that's the sensor. Now I'm going to show you the electrical circuit that you can use to get this working, and I'm going to assume that you're working from your 6-volt battery supply. So the circuit symbol that we use for a DC voltage source is this long line and a short line. And just move that out of the way. So it's a long line and a short line like this. The long line indicates the positive wire. So in the physical circuit, what this is basically your battery pack. Okay, and the two wires coming out of the battery pack, the red and the black. The red is the positive, and the black is the negative. So, so this represents the battery pack. This component here. And in my circuit diagram, I'm going to put in what we call rails. So what I mean by the rails is basically lines at the top and the bottom of the circuit diagram which represent 6 volts up here. So 6 volts is the top line and 0 volts is my bottom line. So these are going to be the rails in my diagram. I'll just move down the top rail a little bit so I can get them all on the screen at the same time. Let's get rid of that bit. No, it's okay. Should be okay with this. So I've got 6 volts at the top and 0 volts at the bottom. They're what I call the rails. Now when you're working on the breadboard, oftentimes you'll use these long continuous connections along the side of the breadboard as your rails. So what I'm showing in the circuit diagram is the top line here and the bottom line down here. They're actually going to be connected to similarly kind of laid out rails on either side of my breadboard. Okay, so there's two sides to the circuit. The first side is the LED side, and that's very similar to what you've already wired up before when you connected up the LED for the first time. So it's the following. It's just got the infrared LED, which is represented by that circuit symbol there. It kind of looks like an arrow with a flat line, and then two little mini arrows coming out representing the light that it emits. So electric current can only flow through this diode in the direction of that big arrowhead there. And when you do drive electric current through it in that direction, you get light emitted out. Now, as I say, you are not going to see the light coming out of this with the naked eye. However, you can verify that this part of your circuit is working once you've wired it up by looking at the blue eye through the camera on your phone. It doesn't unfortunately work on most iPhones, but you can do it on most of the Android phones. It does work. You just look at it through the camera phone and you'll see the light come out. And the reason is that the sensors inside the cameras in your phone are in most cases sensitive to infrared light. So so you'll be able to verify that that bit works. The purpose of the resistor is to limit the amount of current that flows down through that LED. If you just connected the full 6 volts directly across the legs of the LED, you'll get very, very bright infrared light for a very short time, and then it'll burn out and won't work anymore after that. So what you need to do is to place a resistor in series with the LED to limit the amount of current that flows down through it. Now, one of the resistor types that you received is a 220 ohm resistor, and the color code for this, normally we wouldn't write this in a circuit diagram, but I'm just going to write it in here just for clarity, is red, red, brown. So if you look at the stripes on the different resistors that you have received, you'll see that one of them has got red. I will be explaining the resistor color codes to you either later today or another day, but I won't do it just now. And therefore the amount of light that comes out of that LED. So this is the blue eye of the phototransistor. Now the other side of the color sensor, the TCRT 5000. The other side of the sensor is the light detector, and the symbol for a phototransistor is this symbol here. So this is similar to the symbol that we would use for a normal bipolar junction transistor. Some of you might have come across them before. But instead of an electrical signal coming in on the left hand side, there's these two little arrows represent light switching the transistor on and off. Okay, and then this component is also in series with a resistor, but this needs to be a much bigger resistor. So I'm going to suggest that you try a 10 kilo ohm resistor. That's 10,000 ohms. Now the color code for a 10 kilo ohm resistor is brown, black, orange. Okay. Just to emphasize, both of these components here are contained in the sensor. So the sensor contains two different electronic components in a single package. So I'm going to draw a sort of a dotted line around them, just to remind us that this is all the TCRT 5000 here. Blue eye on the left and the black eye on the right. Now the voltage that comes out of our sensor circuit comes out at this point here. And where you're going to be sending this probably ultimately is to the Arduino. However, for this demonstration, I'm going to look at the voltage between here and 0 volts at the bottom using the multimeter. So I'm going to use this meter here to measure that voltage coming out. And we're going to see what happens when different amounts of light reflect into our color sensor. So, if you think about what's happening here, there's a small current that flows down through here. I'll just call it IPT for phototransistor current. So capital I or little I are the letters that we use to represent currents in electrical circuits. The currents that we're talking about here are tiny. So you're talking about of the order of 1 milliamp probably, maybe a little more, probably often a lot less. However, that current flowing down through here is going to continue down through this resistor all the way down to 0. So you've got 6 volts trying to push electric current down through this whole branch of the circuit. Sometimes it doesn't succeed in pushing very much down here because there's no light falling on this phototransistor. And when that happens, you don't get very much current flowing down through here. And as a result, the voltage across this resistor is very low. Now the reason I know that is that the voltage at the output here, according to Ohm's law, which you'll hopefully have encountered somewhere before this, is equal to I times OR. Right? So V equals I OR, that's Ohm's law. Now the I that we're talking about here, the current, is this phototransistor current. It's the amount of current that the phototransistor lets down through this branch of the circuit, and that depends on the amount of light that reflects back onto it. So this is actually IPT here, the phototransistor current. And the resistor that I'm talking about here is this resistor, the 10 kilo ohm resistor. So even if we get a very, very small amount of current flowing down through here, by the time it goes through a 10,000 ohm resistor, very small current multiplied by 10,000 could produce a few volts. And that's what we're relying on here. We're going to see this voltage change, and the Arduino will be able to measure that, which means that your program will be able to react to the change in voltage. Okay, so typical values. Let's imagine that when you're looking at a black surface, so on black, so in other words, when the sensor is pointing directly at a black surface being dark absorbs a lot of the light that hits it, including in a lot of cases infrared light, which means that the infrared light coming out of the LED just gets absorbed, very little of it reflects back and hits the phototransistor, which means that the phototransistor is basically off. So it's like switching off a tap. The water pressure can still be there, but you don't get any flow of water because the tap is off. So in the dark or on a black surface, you get no infrared light reflected back, which means this is switched off, which means the current down through here is tiny. So IPT is approximately 0. Now if IPT is approximately 0, so I'll say 0 amps, then the consequence of that is that the voltage at this point in the circuit here, the voltage across that resistor there, also has to be very small, because 0 times 10,000 is still 0. So therefore V, the output voltage, is approximately equal to 0. I suppose maybe I should call it V out, the output voltage is equal to 0 volts. So in other words, if I'm on a black surface, very little light reflects back, very little light strikes the phototransistor. The phototransistor is off, which means no current can flow down through here. If you've no current flowing through a resistor, Ohm's law tells us that the voltage across the resistor is very small, or 0. And we know it's 0 volts down here, so therefore it's about 0 volts here in the dark. Conversely, if a lot of light reflects back, let's imagine, for the sake of argument, that enough light reflects onto the phototransistor that it allows 0.4 milliamps to flow, right? It's a very small current. What would that mean for the output voltage of the circuit? Well, V out, according to Ohm's law here, V out would be equal to 0.4 times 10 to the minus 3, that's 0.4 milliamps, multiplied by 10,000. So that would be equal to about 4 volts. Now I've just made up this figure of 0.4 milliamps, but it's probably the approximate ballpark. If you set up your color sensor at the right height over the surface, if it's shining out a nice bright beam of light out of the LED, and you point it straight at the surface, and the surface is white and it reflects a lot of infrared light, this is the kind of order of magnitude that you can expect to see of the current. So you will see the voltage at this point go up, you know, to potentially 5 or 5.5 volts even if you get things just right. So that's your circuit. Just want to take a snapshot of that. And you'll notice there's a couple of things to look out for when you're working on a breadboard. So what's underneath each row of holes is a single metal clip, and it's got a few sort of metal sort of finger grabbers. When you put a wire in through the top of the breadboard, it's getting held underneath by that metal clip. So when two things go into the same row, they end up getting held by the same metal clip, and it provides one continuous conducting path from one to the other. So that's how it works. Okay. So I'm going to build my circuit on the breadboard here directly with the sensor. It's not the only way you can do this, but that's the way I'm going to do it. So So I've plugged it in here. You can see I've got two of the legs are here plugged into rows on one side of the board. So I have it in, what is that, rows 9 and 12. A little bit hard to see, so I'll just try and point it out. So that's one leg going into row 9, and that's second leg going into row 12. So that's on one side. And you'll notice if you look carefully on one side of the sensor, you can just see the name of the component written on it there, TCRT 5000. I should have mentioned, by the way, these sensors are very adaptable. You can use them for lots of different things, but they're also phenomenally cheap. So they cost about 10 cents each. So it's a good sensor to get.